Okay, guys, one last part to this final review, and it is over. We just got to cover a little bit about volumes, and we're good to go. So let's talk about this one first. It's not really much to write down. I'm not going to write down an answer to this. I'm just going to talk about it. So we talked about Cavalari's principle, and really kind of how it kind of applies to the opening of calculus. But it's all built on this really kind of simple principle where you have to kind of think about volume not as like this kind of magical thing that appears out of nowhere, but rather like something that's already there that you're just counting. So if you had the stack of 23 quarters and it gets all discombobulated, since it had volume to begin with, like it had 23 quarters worth of volume, you can mess up the stack of quarters and it's going to be just fine. It's going to contain the same volume. This is ultimately why, at least if you're in my class, I really hate this idea that the volume is the area of the base times the height. Like I'm cool with it in terms like it's going to get you the right answer, but it doesn't explain where volume actually comes from. This explains where volume actually comes from. Volume starts with volume. So just because it's not well ordered top to bottom and all these like quarter discs are all over the place, doesn't mean the volume changes. And so Cavalari's principle says this explicitly. As long as each of the individual cross sections is uniform, and whether that be uniform as in they're the exact same size as this is, or like they get progressively smaller as long as they're all similar, as in like a pyramid or a cone, as long as the overall height is the same, you can mess up the stack of volume and maintain the same volume. So these volumes are absolutely the same. Cavalier guarantees it because ultimately, in this particular case, there's still 23 discs worth of volume. And again, if you force yourself to think about volume in this way, as in it's this like way to count things that are already there, then this is really not that big of an obstacle. It is what it is. All right. So down here, there's no directions. I'm going to assume that we want to find some volumes. Now, this is not explaining volume. This is finding volume. So, like, if we use the formula, it's totally fine. You just have to have the right one. And so I'll help you kind of recall some of this. So now this is a sphere. Please recall that the volume of a sphere is defined to be 4 thirds pi r cubed. Now, this is something you'll be given for the final. You don't have to necessarily memorize it. You really have to be good at working it. So the only input here is for the radius. So 4 thirds pi. Um, we have, let's see, 2.8 meters for the radius. And we got to take it to the third power. Now, 2 point is already in a decimal form, so I'm going to make this a whole decimal approximation anyway. So going to a calculator, let's see, 2.8. We're going to go to cube it, multiply by pi. And multiply that by 4 thirds. Okay, so we got, looks like we have an approximate volume of 91.95 cubic meters, or meter cubed if you want to be super technical. Okay, here we have a cylinder. Like this looks pretty weird because it's turned on its side, but it's just a standard cylinder. And so we're going to go with the volume formula being like the area of base times height. In this case, the area of base is going to be the area of the circle, which is going to be pi r squared. So in this case, 18 squared, and the height is 20. Okay, so if we have, okay, so if we're going to keep it in terms of pi, multiplying these together will get you 6,480 pi cubic feet. If you want to multiply that out by pi, you get a nice little approximation of 20,357.5 cubic feet. Either one's totally fine with me. Either one makes equal sense. Be ready for both in the final. Okay, again, we're formulaically driven here, so let's just go ahead and keep rocking it. For a pyramid, we're going to look at 1/3 the area of the base times height. Okay, so in this case, the area of the base looks like a rectangle, so that's going to be 15 times 7. And the height is gladly given to us as 18. Okay, so again, going to our calculating machines. Okay, so we have this, divide that bad boy by 3, and we have the volume of this to be 630 centimeter cubes. A cone is no different than a pyramid. It's taking advantage of the cylinder formula and taking a third of it. So the volume formula here is going to be a third pi r squared times height. So our radius in this case is going to be 3.3, which is half of the given diameter. So 3.3 squared, multiply that by 10 inches for our height. So this is going to be, again, where everything's already in decimal, so I'm just going to keep it there. So let's multiply that by pi, multiply it by 10, divide by 3, and our volume approximation is going to be 114.04, in this case, inch cubes. Okay, so here we have a triangular prism, but it's still a prism, so we're still dealing with the volume being the area of the base times the height. Now in this case, the base, I'm going to use this frontward facing triangle. So the area of the base in this case is going to be 1/2 times 20 times 30, and the overall height of the pyramid is 14, or prism, excuse me. So the area of the triangle is 1/2 base times height, so that's where they get the 1/2 20 times 30. And we multiply that value by 14, and the volume of this guy is 4,200. Okay, last problem. Now we have a composite shape here, which means it's more than one thing together at the same time. Not really a big deal. We just have to understand like these measurements are going to transfer. And so if this guy at the bottom is 8, this is also going to be 8 millimeters. And that should be all that we need to actually solve this. So let's do this in two parts. The first part is like figure 1, and then we have figure 2, which is at the bottom, and we'll just add them together. And so for figure 1, we still have the area base times the height for the volume. In other words, it's going to be 8 times 5 times 5. So just for the top, we have 25 times 8. That'll give us 200 millimeters for the top only. And so now let's find figure 2. The volume in this case is going to be 18 times 8 times 4. Which will give us 576 millimeter cubes. And so the total volume is going to be those things added together. So to add another 200 to the 576, you'll get 776 millimeter cubes. Okay, guys, that is a year. So I know I went fast through part of this. I hope you guys could hear me okay. It's really late at night right now, actually. So I'm a little bit tired. But if you have any questions, make sure you ask your teachers. Come and see us in one of those Wednesday study sessions. Go into your teacher Spartan time, get some help. For the love of God, study all the final, get your notes ready, be ready for this test. It's a lot going on. The test is not easy, but it's totally fair. If you do the study guide and you really understand it, I think you'll be just fine for the test, guys. Okay, so thank you for working hard. We'll see you in class.